I am live. Good morning to some people, good afternoon to others. Thanks for joining us for another session on anti-relativity. And what I'm pointing out is that Einstein's paper on special relativity does not really make sense. And that's the paper upon which Einstein's relativity starts from. So there's fundamental problems in trying to understand what Einstein's talking about in his 1905 paper with starch relativity. And I just have to turn the sound off of the other place. Hold on a minute, sorry. Right. Yeah, so I've got the YouTube up on another computer just to make sure everything's coming through properly. So it seems to be on YouTube, so everything seems to be working all right. And so straight on now with Einstein's relativity, it starts off in 1905, and in my opinion, it doesn't make sense from the first paper. And there's been plenty of time since 1905 to clarify that paper, but it never seems to have been clarified properly. And I've looked on physics forum discussion groups, and there seems to be other people now querying what precisely was Einstein talking about in 1905 and trying to make sense of it. And there are other videos I've found on it now, which I could show, but I think would be a distraction or diversion from what I want to talk about this time, which is I'm just pointing out that what Einstein's saying does not really seem to make sense. So on to the first slide. So I've already dealt with the mathematics in previous anti-relativity sessions of what Einstein presented in 1905 on special relativity. And it's very complicated. It's very difficult to understand what that mathematics is supposed to mean. So as I said, I've got other videos now of people querying, trying to understand what that mathematics means. But this time I want to dissect what he says in that paper and try to make sense of that. Because if you could understand what Einstein was talking about, then maybe you could understand what the mathematics is supposed to mean. And Einstein's relativity is supposed to be a difficult theory to understand, and there is the alternative point of view. Maybe it just doesn't make sense, and that's going to be the thesis of this talk, that Einstein's paper on special relativity does not really make sense. And the mainstream doesn't seem to have addressed that possibility. Mainstream just seems to go ahead with the belief that Einstein's relativity is just a difficult theory to understand, and it doesn't want to try to address the problems of people saying it doesn't make sense. So next slide. So I'm going via part of what Bruce Nappi's annotated copy of Einstein's special relativity gives. And if you want to see the paper, it's at that web address there. Okay. So this is Bruce's paper on Einstein's on the electrodynamics of moving bodies. And so what Bruce notes is that what Einstein says in this paper in 1905 was revised. So you've got Einstein writing his paper in 1905, and since 1905, somebody's gone ahead and revise that paper. And I think the revision just creates more confusion because it does not seem Einstein revised it, but instead it was revised by someone else. So you've got at least two different versions of Einstein's special relativity. You've got the original 1905 paper, and then you've got the paper which was later revised by somebody. So the point there is the original theory, and then there's a revised theory, and there seems nothing by the mainstream to explain what all that was about. They don't seem to explain why is there a difference between the original theory and the revised theory. There's no information about it. Well, it doesn't seem to be. I couldn't find anything. I've been looking at Einstein literature for a very long time, and it doesn't seem to be given by the mainstream as to why there were changes made to the theory. And the point from that is, well, the theory just becomes incomprehensible. You've got an original version and you've got a revised version without information telling you why the theory was revised. But the issue of would the mainstream admit the theory is revised? And the answer is, of course, no. They wouldn't admit something like that. They just kind of blindly go on pretending what you've got is the original theory. So getting into it, Bruce says there's been multiple cases of inaccurate translations in relation to the variables Einstein used in his equations. And I'm going to admit that that is the mathematics, and I'm just going to hope that you've paid attention to the other sessions where we went into the mess made with the mathematics of Einstein. And this time I want to concentrate on what Einstein is saying in his paper and the problems of the maths I pointed out previously. And so skipping over the math notation problem that Bruce points out, we'll get on to what Einstein is talking about. So Bruce points out what Einstein says in line 1 after the heading. So Bruce has numbered the lines in Einstein's paper, and the first line, which is numbered as number 1, is Einstein says, it is known that Maxwell's electrodynamics, as usually understood at the present time when applied to moving bodies, leads to asymmetries which do not appear to be inherent in the phenomena. So we immediately hit a problem. Einstein never gives any references to say what he's working from. The whole paper of special relativity in 1905 gives no references. So Einstein is talking about things and he's not saying where the information is that he's working from. So it is usually understood, but by who? A reference would be nice, but Einstein assumes the reader knows, and that's one of the big problems with Einstein's paper. Einstein assumes the reader knows a lot already about electrodynamics, and Einstein is writing to that sort of reader. And if you don't know that information already, well, Einstein's not going to provide you with any places where you can look to get that information from. So I don't know what he's referring to, and probably many of his readers don't know. Thus, immediately in his sentence, Einstein is incomprehensible. General reader doesn't know what Einstein is talking about, but have to put the unknown aside if hoped to proceed with Einstein's paper. So the point is, line 1, Einstein's paper, he's not given enough information to understand what Einstein is talking about. So as per Bruce, he gives line 2, 3 and 4. where Einstein says, take, for example, the reciprocal electrodynamic actions or action of a magnet and a conductor. The observable phenomenon here depends only on the relative motion of the conductor and the magnet, whereas the customary view draws a sharp distinction between the two cases in which either the one or the other of these bodies is in motion. So, right into another problem here. What is the customary view? A customary view by who? Question mark. Once again, no reference, so yet another unknown. And once again, we've got to put that issue aside if we want to proceed with the paper. Einstein's assuming that the reader knows what the customary view is, and he's not going to tell you where you could find that information on what the customary view is. So Einstein proceeds with line 5 and 6. For if the magnet is in motion and the conductor at rest, there arises in the neighbourhood of the magnet an electric field with a certain definite energy, producing a current at the places where parts of the conductor are situated. But if the magnet is stationary and the conductor in motion, no electric field arises in the neighbourhood of the magnet. In the conductor, however, we find an electromotive force to which in itself there is no corresponding energy, but which gives rise, assuming equality, no, seeming equality of relative motion in the two cases discussed, to electric currents of the same path and intensity as those produced by the electric forces in the former case. And so, noting once again, there's no reference, so it's still another mysterious unknown. So, where's Einstein getting this information from? He's not telling you. Einstein then goes on to line 7, and Einstein says, examples of this sort, together with the unsuccessful attempts to discover any motion of the Earth relative to the light medium, suggests that the phenomena of electrodynamics as well as of mechanics possesses no properties corresponding to the idea of absolute rest. And what Einstein does is he gives no mention of what experiment he is referring to. It's often assumed that he might be referring to the Michelson-Morley experiment, but he does not make it explicitly clear. It is also unclear whether he is imposing the interpretation onto that unknown experiment or whether he is going by others who also think that. References would be nice to clarify things, but in the first few lines, he's just creating mysteries. This sort of thing has led many to think Einstein was not peer-reviewed because peers would surely have asked for references, question mark. What Einstein presents like a paper it looks like a paper that was never peer-reviewed or was very poorly peer-reviewed. And so Einstein's paper, we've got to line 7, and the conclusion so far is Einstein's paper is a complete and utter mess. On line 8, Einstein says, they suggest rather that, as has already been shown to the first order of small quantities, the same laws of electrodynamics and optics will be valid for all frames of reference for which the equations of mechanics hold good. And what we get is a note 1. Note 1 tells us Einstein did not know about Lorentzi's equations when he wrote his paper. So first of all, notice that he's using the word suggest. So we'll go back to that bit. or suggests. It started at the beginning. He says they suggest. So he's saying that it's a suggestion, and so it's probably not absolutely certain what he's saying. He's not providing proof that what he says is what is really going on. Instead, it's much weaker. He suggests. He's making a suggestion, and that suggestion obviously might not apply. You might be able to do something a different way. Then the note is totally mysterious as to what it's supposed to mean. So when Einstein says he doesn't know about Lorentzi's equations when he wrote the paper, what is that supposed to mean? And that's another big mystery. So beyond what Bruce records, Einstein says in his 1905 paper, on the basis of our kinematic principles, the electrodynamic foundation of Lorentzi's theory of the electrodynamics of moving bodies is in agreement with the principle of relativity. So Einstein, in his 1905 special relativity paper, knows about Lorentzi's theory. So what can it mean that he does not know the equations of Lorentzi's theory, which was that note 1. So what Einstein writes just seems nonsense. Notes that have been added to clarify the paper just do the complete opposite and make it even worse to understand. So Einstein knows Lorentzi's theory of electrodynamics, but he's also saying he doesn't know Lorentzi's equations. So how is that possible? It's a total mystery. Next, Einstein in line 9 and 10. Einstein says, we will raise conjecture, the purport of which will hereafter be called the principle of relativity, to the status of a postulate, and also introduce another postulate which is only apparently irreconcilable with the former, namely that light is always propagated in empty space with a definite velocity c, which is independent of the state of motion of the emitting body. So it would help greatly if Einstein had given references, because Poincaré has also talked about the principle of relativity. So that might be what Einstein refers to, but Einstein doesn't mention it as Poincaré. So it might be, looking at this idea independent of Poincaré. Well, on the issue of velocity, I want to complain that velocity is speed and direction. So constant light speed is not the same as constant light velocity. There's a problem here in the translation that Einstein might have meant speed here and not velocity, but I'll pass on going into that in more detail, just noting that it's another problem of confusion. Does he really mean light velocity is constant, what he's dealing with in this paper, or does he really mean it's talking about light speed being constant? So according to Wikipedia, it says of Poincaré, and this is Poincaré, in 1904, he expanded that principle by saying the principle of relativity, according to which the laws of physical phenomenon must be the same for a stationary observer as for one carried along in a uniform motion of translation, so that we have no means and can have none of determining whether or not we are being carried along in such a motion. So Einstein might be referring to that question mark, but Einstein gives no references. It was bad in 1905, but would help with clarification was later made as to whether Einstein was referring to Poincaré's theory, but no such clarification seems to have been made. So Einstein paper 1905, it's bad that he doesn't give references. He would have clarified this if he was talking about Poincaré's relativity principle, and later on he still doesn't clarify it. So it's a total mystery. if Einstein 1905 was writing about Poincaré's theory or not. In 1905, Einstein doesn't tell us, and after 1905, when he had a chance to clarify things, because of his lack of references, he doesn't. And this leads people to think that Einstein was a plagiarist. And this is pointed out in a previous session where I asked the question, was Einstein a plagiarist? What you have with Einstein is he's talking about things that seem to be dealt with by people earlier. And with Einstein not giving references to what these other people were saying earlier, it makes it look like he's just copying what they're saying without giving them credit, which is what a plagiarist does. So now we're on to line 11, what Einstein gives. These two postulates suffice for the attainment of a simple and consistent theory of the electrodynamics of moving bodies based on Maxwell's theory for stationary bodies. And my note in that is I don't see how, in what he proceeds to give in the rest of his paper, that he attains such a thing. And in line 8, he was saying suggests. So he is just making suggestions. And so is he only suggesting such a theory or what? So it's line 11. Is he still making a suggestion or not? If he's only suggesting a theory, that leaves the option that could go along with another theory. If not suggesting, then maybe he means it's the only theory for electrodynamics of moving bodies. So what does he mean? It's just more layers of incomprehensibility with each line. Each line is creating a mystery. You've got this mystery, and then it will not being able to understand what he means, and then he has another line, and it's more mystery. And all these mysteries could be clarified by Einstein. In 1905, he writes a paper without any references, and that makes it all very mysterious as to what he's talking about, makes it incomprehensible. But he could have clarified it after 1905, particularly after 1919, when he became famous. He could have gone back and clarified what he meant in his paper. But no, he doesn't do that. The paper of 1905 is left to stand as it's saying without giving any references, but with only some amendments made to it, which make the paper even more mysterious. Einstein then goes on to line 12 and 13, and this is where the big problems are starting now, because he's going to talk about the ether. Einstein says the introduction of a luminescent ether will prove to be superfluous inasmuch as the view here to be developed will not require an absolutely stationary space provided with special properties, full stop. Oh, no, not full stop, comma, nor assign a velocity vector to a point of the empty space in which electromagnetic processes take place. So this is all more mysterious things that Einstein's coming up with. So Einstein in line 12 and 13 seems to be identifying ether here with a Newtonian absolute frame of reference. But there's a great deal of things written about the ether concept. So when he says ether superfluous, does he mean just this version of ether, or does he mean all types of ether? Once again, it requires clarification, which he never was never given in 1905 or later as to what he means here. So Einstein's writing just fails to make sense. He's talking about ether, and it fails to make sense what he's talking about. Is he talking about Newtonian absolute frame of reference? Question mark. Don't know. He doesn't properly clarify it. And if he's talking about the ether being that, then he's saying, oh, there's no Newtonian absolute frame of reference, but does that exclude any other type of ether? Einstein's not telling you. He's not going into sufficient details here to explain what he's talking about. It's just layers upon layers of mysteries. So in 1919, this is the sort of headlines of what happened when Einstein became famous, and more people took attention of his work. So in 1905, when he first published his paper on special relativity, maybe not many people paid attention to what Einstein was saying. They maybe looked at his paper and thought it doesn't make any sense, and they just gave up on it. But when he becomes famous in 1919, this is when people start thinking they need to understand Einstein's relativity if they're interested in physics. So close up on the headline, and my throat's going, so I need a sip. It says a book for 12 wise men. It means the book on relativity. You've got to be a wise man, and that was we're talking about it then as wise men. Nowadays, you probably have to say it's wise people. You have to be a wise person to understand it. So you wouldn't exclude women. But at the time, it was mainly men dominated. So relativity is supposed to be something for wise people to understand. And no more than there's 12 in all the world could comprehend it, which is the Einstein's relativity. And this is according to said Einstein, when his daring publishers accepted it. So his book on relativity, Einstein says, well, only 12 people, men in his time, could understand it. You have to be very clever to understand it. So straight away, the publicity was being declared, you had to be very clever to understand the theory. And the alternative view to that was that the theory was just nonsense. And I've already gone through his 1905 paper, pointing out the problems and trying to understand what is being said in it. And so reading it, you can just, unbiased reading of it, you could just come to the conclusion, oh, it's nonsense. It's nonsense. He's just saying things that are nonsense. It's not clarifying anything. But the big publicity is, no, you shouldn't come to that conclusion that it's nonsense. You should instead come to the conclusion you have to be very clever to understand the theory. And so straight away, the pressure is on the reader. If you don't understand what's being said, it's not the theory that's nonsense. It's just you not being clever enough to understand it. Anyway, the point of view that what Einstein was saying was nonsense was well known at the time. There was a lot of people coming out after Einstein became famous saying that Einstein's relativity was nonsense. And you've got books like this, which was a German book published in German, 100 authors against Einstein. And so that's 100 people thinking Einstein's talking nonsense. When it came to deciding whether Einstein's theory requires superintelligence to understand it versus it was nonsense, the mainstream went for the idea that you had to be really clever to understand it. So never addressed properly all the criticisms that Einstein was subjected to after 1919 by people saying what Einstein's saying was nonsense. Hence why reading Einstein find it does not make sense. No one in the mainstream has tried to clarify what Einstein was saying. They've just left it as you've got to be really clever to understand it. And they've not clarified it for people who are pointing out they don't understand it. So, of course, when it comes to teaching Einstein's relativity, the educators don't go word by word by what Einstein says. Instead, they give something else. So let's look at what the educators say about relativity. Some point I'm making is Einstein's relativity theory of 1905 is not usually presented to students as for the place to understand special relativity. Instead, the educators go in a different direction. So this was reported in the American Journal of Physics, and it's by a person called Rolf, and he points out there's about 2 myths about special relativity. And Rolf says in his paper, in the course of a century, the special theory of relativity has given rise to a variety of misconceptions. I address 2 significant instances, and these misconceptions, in my view, come about because what Einstein says in 1905 and so forth, it's impossible to make sense of, and so you've got to sort of try to add more to the theory to try to make sense of it. And then what does the mainstream say? Well, you've misunderstood theory if they don't like your version of trying to make sense of Einstein. So what Boaf points out is what is being taught is the Lorentz transformations reduced to the Galilean transformation when the ratio V divided by C is small. And that's what is taught, but Rolf points out that is mathematically false. So i.e. physics students are being taught to believe false mathematics. So hopefully you know what the Lorentz transformation is. That's a piece of mathematics, and Galilean transformation, another piece of mathematics. And so what Rolf is pointing out is the mathematics that physics students are being taught for special relativity is just a load of nonsense. Next, and he points out that the phrase the constancy of the speed of light has changed its meaning. And so this is just 2 examples of the type of myths taught to physics students. And the phrase constancy of speed of light is totally ambiguous in my point of view. You kind of like you read it in Einstein, and it's very difficult to understand what he means by that, especially since you've got the speed and velocity confusion. Is you're talking about light speed being constant or light velocity being constant. It's all very confusing, and people have interpreted that phrase, the constancy of speed of light, in lots of different ways. And so whatever Einstein meant by it, well, people after him have interpreted it in different ways. And that is what creates the myths. And there are lots more myths that are being created around relativity. And what was being pointed out by Rolf is just 2 examples of the myths. Basically, though, Einstein's relativity is a total mess. So one of my friends, Dr. Lowe, one of his papers is this. It's on the criticism of Einstein's equivalence principle. Einstein's got it all wrong on that. And Dr. Lowe points out to me that physicists are bad at mathematics and make a mess of it. They make a mess of mathematics. So physicists are just happy to just blunder along and mess up mathematics. And Dr. Lowe also points out to me, while pure mathematicians that are good at mathematics know nothing about physics and are unaware of how badly the physicists are making a mess of their mathematics. And so that's how we end up with something like Einstein's relativity, which makes no sense. The physicists in the mainstream are just satisfied with making a mess of things. Physicists are like students that live in an untidy bedroom. They are blind to seeing that they live in a mess. To them, the mess is totally normal and how things should be. But as I pointed out now, reading the first few lines of Einstein's relativity, it's a total mess from the very beginning. Finish, and that's thank you is the talk. Just an introduction to what Einstein's saying, pointing out it doesn't make any sense. And it's required people to come after him and try to make sense of it. And those people that come after him have only just carried on creating a mess. So if Einstein had a bedroom representing his theory, it would look like that. And people who come after him have just carried on making it into a more disordered mess. They haven't been bothering to tidy things up. They've just been making the mess bigger. So thank you. That's my introduction to this. Thank you. So we can open it up now to sort of discussions. Close. We move. Hi, hello, on full screen. Anybody in the green who wants to say anything? Yeah. Oh, you, Franklin. Yes, I think he wants got. Oh, he wants got higher. Hello, Franklin.
Hey, Roger.
Okay, so that's a short talk I gave. Could have gone on a lot longer. I had a video, but I thought that would be a diversion.
Yeah. So trying to go over some of your points here. I'm not sure that you pointed out that whether it didn't necessarily make sense. It's more like it's not very well explained, right?
That's the word. Yeah, explain.
You've got no references.
Yeah.
And what he says can be interpreted in many ways.
Yeah.
And things like that. Although it may not necessarily be the case that it doesn't, I don't know, make sense.
He assumes the reader already knows a lot about electrodynamics, so he's talking to a reader who doesn't need references.
And yes, well, the first thing he talks about, everybody seems to think that the 1905 paper is about, relativity, but he starts out in this very opening paragraph, as you point out, about Maxwell's equations. So this has to do with resolving a problem with reconciling relativity with Maxwell's equations. He brings up this specific example of a magnet and a wire. And so he says this thing that, if there's a, what exactly does he say? So I have the 1905 paper here from Fermilab here, right?
Yeah.
And what specifically says that the reciprocal electrodynamic action of a magnet and a conductor, okay? So the customary view is that if the magnet is in motion and the conductor is at rest, then an electric field with definite energy is produced, and that electric field, I guess, induces the current, is what he's saying. And then he brings up the opposite, which is that if the magnet is stationary and the wire is moving around, then there's supposedly a different thing happens, which is that an EMF is generated, an electromagnetic force, which means there's something which is propelling the electrons through the wire, but apparently not an electric field. So this seems to be the initial crux and confusion that perhaps he's trying to solve, because apparently Maxwell's equations indicate that there are these two different phenomenon going on, depending whether it's the magnet moving and for whether it's the wire moving. And I think it's
important. Know who's saying that. You don't know this customary way of talking about things is who's saying this.
Yes, I'm not. Now, me personally, I think this is probably the whole crux of the problem. If this is the problem he's trying to solve, because intuitively, for I think most people, it's the relative distance, relative motion between the wire and the magnet, and it doesn't, and the mechanism behind both of them, I think, must be the same, right? Although Maxwell's equations does, I think, looking at this more carefully, Maxwell's equations do say that a variable magnetic field does in fact generate a real electric field, you know, actually in the complete absence of any actual electrons, and this can be done in vacuum because this is Maxwell's addition to Ampere's law, and this is what makes it possible for electromagnetic waves to be propagated in vacuum. See, because
he doesn't mention Ampere's law, as far as I remember. He doesn't. So you're going. If he mentioned where he's getting this information from, you could go back and check, see what the difference he's doing.
well, he does definitely references Maxwell's equations. Now, apparently, he didn't somehow know about Lorentz equation. I don't know how that's possible. I mean, probably that just meant that he just wasn't paying any attention to anything going on. But apparently, he knew about Maxwell.
Yeah, but he also admits to knowing about Lorentz's theory, but he doesn't reference what he's read on it. So,
well, it's not clear. See that one little reference there, that number one reference.
Yeah, he knows about Lorentz's theory, but he doesn't say where he read about it. So the background information that Einstein's going by, you just don't know what it is. He doesn't tell you. So it's rubbish. The whole paper is just rubbish. You're trying to read the paper, and you're trying to impose sense onto the paper, rather than knowing definitely what Einstein's talking from. So given that you don't know, you got all this ambiguity with the paper, you're trying to add more onto it to try to make it make sense. Hence, you create myths. And so Einstein doesn't mention that Lorentz transformations reduced to Galilean transformations for V over C thing. He doesn't mention any of that. And that's an interpretation that's added later. So that bit of mathematics, which is false, gets added to the theory further on, and that's a myth, and that's taught to physics students. So everything is a myth. It's all like somebody's trying to make sense of what Einstein's talking about, and they're just making more mess.
Well, I don't know that it's quite that bad.
It is. It is as bad as that.
Like I said,
mathematics is a total mess in trying to understand what it's meant, and so what you need then to do is look at what Einstein is saying to try to make sense of that mathematics. But what Einstein is saying doesn't make any sense because he's not giving you the background information. The whole paper is a total mess, and you're trying to then impose interpretation onto it to try to make sense of it. I mean, he doesn't mention this Michelson-Morley experiment. So some people interpret that to mean he came up with a theory independent of the Michelson-Morley experiment, where other people interpret it as Einstein was working for the Michelson-Morley experiment and then came up with this experiment. So you've got no background on that. You've just got people with different opinions.
Well, that is different from it actually not making sense. So, I mean,
it doesn't make sense. Where did the theory come from? So, ideally, a physical theory has to come from experiment, but Einstein's not referencing what experiment he's going by. So straight away, you've got a problem of where did the theory come from? You haven't got an experiment saying where it came from. People try to make sense of it by saying it comes from the Michelson-Morley experiment, but Einstein does not explicitly mention that. So another way of looking at him is he just imagines it, or he has his thought experiments, he dreams a theory out, and suddenly, oh, look, it fits experiments. So you've got a break with the scientific method. You're supposed to be going by experiments, but Einstein, it looks like, doesn't on the initial.
Well, he doesn't really reference really anything. But once again, I would argue that that's a problem of ambiguity rather than say doesn't make sense.
Like with ambiguity. I'd say ambiguity doesn't make sense.
No, I would say that those are distinctly different things. For example, I would say not making sense. Like the first thing when I would read this whole paper, the first thing that did not make sense was his definition of simultaneity, and definitely the way he synchronized clocks. That
doesn't
make any sense at all. It's like,
and what he's saying with that definition, I think, is ambiguous as well. So it's ambiguous, that definition, and I take ambiguous as meaning it doesn't make sense, because you've got ambiguous things being said, and in order to make sense of it, you've got to try to impose an interpretation onto what he's saying. But you don't know what that proper interpretation is supposed to be. So some people just get it wrong. They come up with an interpretation which turns out to be a myth. It doesn't work.
I found Poincare's relativity paper, so I did link that there. And, when reading Poincare's paper, I think he is making a lot more sense as to what exactly he's talking about, say, compared to Einstein. So perhaps people are interested in what it might actually mean. They should go read his paper, because I think Poincare goes into it.
Sorry, whose paper?
In a bit more detail.
Whose paper? Sorry.
The paper is called, which I referenced from longstreet.typepad.com, is The Principles of Mathematical Physics by Henri Poincare, published, basically the same time, November, not 1905 as well.
Oh. Yeah.
So, he mentions the principle.
Wolfgang Pauli tried to give his version of relativity. And there is lots of papers and books and things interpreting what relativity means to each author. And for me, they're contradicting each other. Different authors have put in different interpretations onto relativity. And I've tried to point out examples of that in earlier sessions where you got people who think relativistic mass is not a real thing in relativity, when you've got other people who think relativistic mass is. So you've got different interpretations of relativity. And it's all due to Einstein being ambiguous. He's not given references to properly explain his theory. And it's all just built on that. He says that. It keeps building, and then people have to try to impose an interpretation onto it, and that interpretation is different for different people.
Well, I've always found the most striking, interpretation of Einstein is to say the second postulate. So that second postulate is always stated by the mainstream as the speed of light is constant in all inertial reference frames. That is the way the second postulate is stated. But
it has been gone in different interpretations. Kind of like there are people that interpret.
But what Einstein says means nothing. It doesn't even contain the same words, right? It doesn't even contain the same words. The actual postulate says any ray of light moves in the stationary system of coordinates with the determined velocity c, whether the ray be emitted by a stationary or by a moving body. That's what the second postulate actually says. But yet that gets interpreted into the speed of light is constant, or this is literally gets interpreted as that, or that the speed of light is constant in all inertial frames. It doesn't have anything to do with whether the ray is emitted by a moving or stationary
problem with that
body.
is there's lots of interpretations you get onto that, because it might be that he's referring to inertial frames only. Speed of light is constant only for inertial frames, and for non-inertial frames, it's not constant.
I mean, that's not an interpretation. That's a complete rewrite, is what.
Well, this is the interpretations. What interpretations are doing is complete rewrite. I just said yes to a coffee. So, to wife's come in, can I say coffee? Yeah, so that is the problem. These interpretations are completely rewriting the theory. And I tried to point out that Einstein wrote his paper in 1905, and then somebody's revised it. and we don't really know who revised it. I think it was Sommerfeld, but I'm still investigating that at the moment.
Well, I'm still trying to determine what Einstein himself really meant, because he does
Yeah,
mention the constancy of the speed of light in his
yeah.
paper. So, but what exactly does it mean? I mean, to me, it could mean two possibilities. Is that the speed of light is constant in the same sense that the speed of sound is constant,
Yeah.
in that clearly in that the speed of sound does not depend upon the speed of the emitting
Mhm.
device, right? So whether you're in a speeding
Well,
car or
Einstein doesn't compare light to sound. He doesn't tell you about that
yes,
either.
he doesn't do that. But this
He
is
doesn't do
one
that. So
way.
that would be helpful if he said, "Oh, the speed of light is like the speed of sound." That
Yes,
would be helpful, but he doesn't say that.
if he did that, then we could kind of understand what he meant
Yeah, but he doesn't tell us.
by well, this is the only way that the speed can be independent of the moving of the moving body, right?
Mhm.
So there we can see that the speed of light would be constant. It's independent of the moving body, and it's always relative to, say, the medium, which he says doesn't necessarily need to be.
Well,
Well,
it's
the fluid.
ambiguous. It's ambiguous as to saying whether he's saying the medium for light exists or not, because what does he mean by light medium in this particular paper? Does he mean the Newtonian absolute reference frame? And he doesn't go into details to explain whether he's accepting any other types of ether. And then you go to what he says in 1920, and he seems to be accepting some sort of ether. So what he's saying about ether is just totally ambiguous as well. So
I've been
you
watching
got
a bunch of videos, one of them by Brian Greene, and
yeah
he had these two characters, you know, Gracie and I forget what the other character is,
yeah
but he had an animation showing that there's these two cases where we have one character who is running with his flashlight,
yeah
and showing that no matter how fast or whether he's still, the light still propagates at exactly the same speed,
yeah
which is the same as interpretation as it being like sound. But on the other hand, we have the other character, Gracie, who has got this light speed detector, and showing that she is running back and forth. And no matter whether she's running towards or running away from the light, that it still measures 300,000 miles per hour all the time. So, I mean,
mhm,
but he brings out the point that the only way that can happen is if you screw around with the clock that Gracie is running around with, so that no matter which way she's running, she still measures
yeah
out that the beam passing through her detector takes exactly the same amount of time. Because this is kind of it's kind of like your worldview. I feel like it's
yeah
like if you could have either like a geocentric view, where let's say the Earth is at the center of the universe, and
yeah
then everything else moves around, right?
yeah
And that wasn't necessarily a wrong theory, because they could, using that the geocentric theory for thousands of years, could accurately uh, detect the retrograde motion of the planets, and
yeah
everything worked out. And as near as they could tell, it didn't work. It's just that was the one thing that you had to do if you wanted to put a pin on the Earth. Now, there's the same thing with relativity. That if you want to put a pin on the speed of light, that means you have to change length and you have to change time,
yeah
which is what the critical thing is, right? But you are just putting a pin on something. If you put a pin on the speed of light, then time and length have to change, or but that contradicts our intuitions, where those things don't change. And so that would mean that, say, the speed of light would have to change. That when Gracie runs around, that when she's running towards the light, she should measure a higher speed of light. When she runs away, she should measure a lower speed of light. It's
yeah
like I don't know. It's like that kind of experiment would seem to be actually something we could actually do today with super sensitive clocks and time delay optical loops
But
and stuff like that.
you got
Yeah,
the
that could be
problem there of how does Einstein's relativity want experiments to be done? and you've got Einstein's way of synchronizing clocks. So uh, you've got a problem that Einstein probably wants experiments to be done in a certain way.
Yeah, well,
That's what,
that brought up the problem of like, I think his clock thing says that he wants to make it so whatever the actual what the clock actually reads,
yeah,
7 p.m.
yeah.
is say the actual time that should be considered.
But
But this
you
is what's
start,
wrong with
you've
his.
got a, you've got a
Well,
synchronized clock so that light speed is constant.
well, see,
So
that may be a part where it doesn't make any sense,
sorry,
right?
yeah,
Simultaneity means that these two events happen at exactly the same time,
yeah,
the same moment in time,
mm-hmm.
not that 7 p.m. on my clock is equal to 7 p.m. on this clock, and therefore anything happening when those clocks are the same, that is simultaneous. He seems to want to say that that is what is actually simultaneous.
The problem is the clocks are separated by a distance, so
But
and
that
also
is
and
just clearly
speed and so
wrong.
forth. Sorry,
that is clearly wrong. See, this is the first thing that to me doesn't make any sense, which is how he synchronizes clocks.
Yeah,
which is by sending light signals between the two clocks.
Yeah.
And it's like, well, how does that synchronize clocks? The way you synchronize
that,
clocks is you bring them together,
yeah,
you make sure that they're running all at the same time, and then you take them apart, and that's how you synchronize clocks. You don't synchronize clocks by sending signals between them because we don't know if there's anything interfering with the signals coming, right? So that's the first genuine thing. This is how I distinguish not making sense versus being ambiguous, right? That to me just doesn't make any logical sense. That you could make sure to have clocks which are exactly synchronized by sending signals through them. It's difficult even with GPS because that's exactly what GPS has to do. GPS has to synchronize all the clocks so that when it reads 7 p.m. on one clock, it reads 7 p.m. on all the clocks and on the clock on the Earth.
Yeah, but
all at the same time.
The people who believe in relativity say GPS works by relativity, and it's sort of our GPS engineer, who sadly passed away, Ron Hatt, says it doesn't. So you're straight away into an interpretation problem. You've got the people who believe in relativity.
It can be done, but I give the example of, say,
you
have like 4 clocks and they're like temperature dependent. Like the old pendulum clocks are very susceptible to temperature variations because when it gets hotter, the pendulum would get longer and it would just like tick slower, right?
Yeah, I don't think that's a real time effect, the time dilation effect.
Well, no, I'm just trying to say this is what's wrong with this whole definition of simultaneity.
Yeah, but
so let's say you have 4 clocks.
People could start saying, yeah, temperature does affect time dilation. Some people could take that interpretation, and some people could take the interpretation that it doesn't. So once again, Einstein's ambiguous on that issue because he's not talking about that.
Well, I think the way that he's looking at it is just simply wrong because it's like you have 4 clocks, they're all running at slightly different rate due to some environmental factor. And then you try and do something like, well, let's just time this event of like, me dropping a marble from 1 foot high. Mm-hmm. And then you do this experiment in 4 different places with these 4 different clocks at 4 different, say, temperatures or something. And then everyone comes up with a different number, right? So of course that's ridiculous because your clock standards aren't the same. So how do we fix that? Well, we have to make sure that all the clocks are actually reporting the same simultaneous events. And you would do that by going, okay, your clock read this, your clock read that. Your clock was 2 seconds behind. So what you're going to have to do is you're going to have to adjust your clock so that it ticks the same as my clock, and my clock gets the same as your clock. And only when we have all of our 4 clocks actually ticking at the same rate.
That is how you would do it by Newton, but Einstein seems to be imposing that time is different for different observers. So
but that would be like doing the science experiment with the 4 clocks, which are not all clicking at the same rate.
Yeah.
So, example, like if you have a clock and you notice that it is like if we do the time dilation experiment where you send a twin out at high speed, high relativistic speed, I mean, what you would do is that you would not take the clock that's in the speed of the Earth in spacecraft as being the time, because we know that that clock, say, is going to be running half the speed as the one on the Earth. What you would do is you do the calculation, and then you would make the clock in the spacecraft run twice as fast, so that then they would be running simultaneously, right? Now, maybe all the processes on the spacecraft are running half the speed, but in order to say anything about simultaneity or time, is that you would have to make sure that the clock in the spaceship is running twice as fast so that it ticks at the same rate. And you can always do that. Anywhere in the universe, no matter what speed you're at, you can adjust your clock so that it will run at the same as another clock in any other inertial frame, right? So that sets, I think, a more common sense notion of simultaneity, right? It's not that the clock in the spaceship reads 7 p.m. and the one on Earth reads 3, and then we're saying, oh, he traveled into the future. It's like, no, he did not travel into the future. His clock is just running at a freaking different rate, right? But Einstein and I don't know, you have to come up with these things. The one of the most remarkable effects is called the relativity of simultaneity, which allows like things like what exactly I said was like, I've gone so fast, I've gone into tomorrow, right? Kind of things. And that just doesn't seem right from our intuitions. You shouldn't be able to say.
Yeah, I think that's all starting to go farther beyond what we're talking about. I mean, I didn't get onto the clocks. Einstein in the paper does actually get onto the clocks in Bruce Nappi's paper, but I didn't get as far as that. I was pointing out I was confused already in the first 13 lines. So it's only getting more confusion as you go deeper into it, and people would try to impose ideas onto it to try to make sense of what Einstein's saying. Okay, so thank you. Okay, so I go back? You finished? I see what other people are saying.
Rambled on and help you.
Okay, thank you.
Let's see if we've got something in the comments here now.
Yeah, I'll go through the comments. I'll get to the comments now, shall I? Do you want to deal with the comments?
Well, I haven't had a chance to take a look at too many of the comments here.
Yeah, do you want to go through them with me?
Yeah, let's see what we got here.
Have a look at the first few. Some of the time they just go off onto a diversion.
I think there's an interesting comment here by Cornelius here, which says, he's not saying it doesn't exist, but he's saying that since the motion of the ether can't be detected by light, that you really can't use it as a reference. Yeah. Although that's curious because now we know that we can detect, say, the 24-hour rotation of the Earth through the ether. Yeah. So I'm kind of wondering if Einstein had known about that.
Yeah.
Would that have changed what he thought?
Yeah.
Because definitely we can detect the 24-hour rotation of the Earth, the GPS satellite systems, when they calculate the time dilation transformations, they rely on the ECI, Earth-centered inertial frame, as being the stationary reference frame. So it definitely has there is a special frame which it can be detected on. But I thought that is interesting. So that's one interesting comment.
Yeah. Yeah, so I wouldn't take superpurpose to mean the words don't exist. I would say that Einstein was still accepting existence in the ether, even in his 1905 paper. It's just that the mainstream interpretation onto Einstein is that they interpret him as saying it doesn't exist. So they're quoting Einstein as saying the ether doesn't exist, which is really just an interpretation imposed onto Einstein. Yeah.
This is another question here about Maxwell's equations. Now, in the videos I watched, the thing is that Maxwell's equations predict the speed of light to be 300,000 miles per second. But the question is, relative to what? Right?
Yeah.
I mean, that wouldn't make any sense.
Correct.
If you cannot establish a frame of light. I mean, a reference frame for your 300,000 miles per hour, right?
And I think the assumption was before Einstein that speed was relative to an ether frame. And so with this Einstein coming in and confusing things about the ether, it's sort of like these people say there's no ether frame for the light to be measured relative to. So it's all Einstein is creating confusion there.
I'm considering I should make a video about, what is our intuitions about these things. For example, if you have the train and it's moving, Einstein would say, well, it's like the train is stationary and the earth is moving, which of course is completely contrary to our intuitions. So I want to get back to a more intuitive view. So I would just enforce the law that whoever's got the most mass wins. So whoever's got the most mass, say the earth in this case, would be defined as stationary, and only the train could be said to be moving in that case.
Yeah.
And then ultimately, there are experiments that we can do to determine our speed, determine whether we are in motion or whether we are stationary. All you have to do is you can either apply the rule I just gave, which whoever's got the most mass wins. And if you are moving relative to the thing that has much more mass, then you are moving. But also from a scientific view, you can look at the sphere of stars around us, or ultimately you can look at the CMBR, the cosmic background radiation, and you can look at the Doppler shift, and then you can determine your exact speed through the universe in an absolute sense. So in to contradict what is said in the paper, which is you cannot determine whether you are in a motion, you are in a state of absolute motion, that now is currently wrong. Yes, we can determine with scientific precision whether you are in fact in motion or not. And so we would measure that absolutely everything is in motion, say on the Earth, because it's moving through the CMBR towards some star at, an X amount of speed. Absolutely, right?
Well, we got what Einstein says in 1905 without no explanation of how would it fit in with what we know about physics now.
Yeah, a lot of things have changed in physics. It's like a lot of people, I was just reading, didn't believe in the existence of atoms, right? And they stuck to that till their death. Yeah. But would they have said that if you showed them a picture? Here's an electron scanning microscope, and you see that thing? That's a silicon atom, one of them, right? You can see it with your eyeballs, right? So would they have said that? Would they have stuck to that position once they could actually, see it with their eyes?
I don't know. Don't know. So I think it was positivism was the philosophy they were going by. You only wanted to base things on observables, and so since the atom was not observable, they didn't want to believe in the existence of it. But it seems like in physics theorizing, you've got to postulate things which are unobserved, which are then give effects which are observed. So,
there were a bunch of questions here about this whole question about magnets and wires, right? So Quest is asking, if either the wire or magnet is in motion, doesn't it produce the electric spark?
Mm.
Now, I would say, well, I mean, I'm thinking he's asking, whether or not the magnet or the wire moves, we still see electric current, and it would still produce a spark if we were generating electricity that way. And it's like, yes, it does. But the thing about Maxwell's equations with his Maxwell's addition and the thing called displacement current is that he's saying that there doesn't need to be even a wire present. But if you just spun a magnet around, that should be generating electric fields, which I would say is patently false and has never been demonstrated by any experiment. But yet that is what is required to get the electromagnetic wave equation to work. Because if electric fields require charges, then obviously there's no charges in vacuum. Therefore, electromagnetic fields could not ever possibly propagate.
Mm.
And personally, I think that's where they should have stopped right there. They should have said, sorry, light cannot be an electromagnetic wave. There's no charges in space.
Yeah.
So sorry. But no. But Maxwell came up with displacement current to kind of be the stand-in current for
that was to make the maths make sense, wasn't it? So he added that term in. So it
that's kind
depends
of
on
that whole
philosophy again. Are you going to try to make the mathematics make sense and put in things you're not observing, or are you just going to stick to what's observed? There's a lot of philosophy questions for physics in the background.
Yeah, what do you think of this comment here? Einstein's paper was considered a review paper of Lorentz's work.
I don't know who that. Some people might have taken that interpretation, but Lorentz, I think, was saying that there was an ether, and so Einstein's paper seems to be in conflict with that. It's depending on how you're interpreting what Einstein says when he says ether is superfluous.
Well, it's like the main time dilation formula, which has the square root of v squared over c squared. That the gamma that comes from that is called the Lorentz that's called the Lorentz factor, right? After Lorentz, right?
Gamma factor, Lorentz factor.
The gamma factor is the Lorentz factor, which is based off of Lorentz ether theory, which depended upon the existence of an ether, right?
Yeah. So I don't think it was considered a review paper of Lorentz because Einstein didn't mention what paper of Lorentz he was going by. If he was doing a review of a paper, surely he should mention what that paper is.
So we have another comment here about where there is electricity, there is magnetism. But the question is, what about, there's a difference between there being electricity, which is the movement of electrons, and just electric field. So you could have an electric field created by a bunch of electrons, and that can extend out into infinity where there are no electrons. So, but is that considered electricity?
Yeah.
See, this is the important distinction, is that the electric field can exist without there being any nearby charges, right?
Yeah.
But does that mean that that's electricity? But does that apply, say, I don't know, in the vacuum of space? It's like, well, yeah, the vacuum of space could still be influenced by the electric field. But is it really, out there disconnected from the charges that generated it? That's kind of the weird thing.
Yeah. Okay.
Now, Robert's pointing out is that Einstein's always doing thought experiments.
Yeah.
Which could, in fact, be complete nonsense.
Well, I don't think, you don't say that, but you could say that the thought experiments are nonsense. Somehow the thought experiments are supposed to explain what's going on for actual physical experiments. It's sort of like one of his experiments is he's uh, looking in a mirror, and then he can see his face in the mirror. Then he wonders what happens if I travelled at the speed of light. Would I still see my face in the mirror? And so he's got all these thought experiments, which you don't really. It's very difficult to understand how it's supposed to connect to actual physical experiments.
Yeah, another example of a thought experiment was like you have two people in a train who want to sign their treaty at exactly the same time.
Yeah.
And, this is the definition of relativity of simultaneity, which is at sufficiently high speeds, the people on the outside will see that the person on the rear of the train signed the treaty earlier than the person in front of the train, but yet the people inside the train see it happening at the same time. Now, the problem is like, has that ever been actually demonstrated, right? Because can you actually, see that? And of course, the thing that people say is that, no, you can't do that because, we would need a train that can go at least half the speed of light. We don't got one of those. So we find out that doesn't work.
Yeah.
And another thought experiment, of course, is the twin paradox experiment, which I was just recently watching a video which says that it's solved because if you take into consideration the time contraction and the length contraction, you will find out that the returning twin will in fact be younger.
Yeah.
And that will be the solution, that there's no paradox, right? This is like twisting around space and time, and if you do that in the right way, it turns out that the traveling twin does properly end up being younger and not older. Although that brings up the problem that if that's true, then you have yet another method of determining whether you're in motion or not.
Yeah.
Right? You could always just say, okay, let's see who's in motion or not.
Well,
let's watch the clocks, and whoever clock runs slower, you're in motion.
Exactly. That's another contradiction in there with the twin paradox.
So even if you can solve the paradox that way,
if somebody's clock is slower than the other person's after a trip, then surely that means there's some sort of absolute frame, which seems to be denied. So it's very confusing. And I found professor who seems to agree with me. I'll put him up. Here we go, Professor. And he says, Professor Harlem, he says, exactly, we can only understand clearly that there's nothing to understand in Einstein's paper. It's just nonsense. And I think that's agreeing with me. And he's got a carry-on comment. And he says, the term relativity is vague and misleading. We should talk only about relative motion, uniform motion, etc. Yeah, so Einstein's paper doesn't make any sense, really. Einstein's paper in 1905 should have been concluded. It doesn't make sense. And in 1920, around that time when Einstein becomes famous, they should have made some effort into clarifying things, but they didn't. They've just left it as something that doesn't make sense. And in a modern context, it still doesn't make sense. The whole paper is just something that doesn't make sense. So the mainstream, when they've told us you've got to be very clever to understand it, really, they're ignoring the possibility that Einstein's paper doesn't make sense. Really, that's the proper conclusion. Einstein doesn't make sense. And I think Professor Hallam is agreeing with that. You read Einstein's paper, it doesn't make sense. And that should be what everybody reads. When everybody reads it, everybody should reach that conclusion. They shouldn't reach the conclusion, oh, it's something for only clever people to understand. Instead, it should be thrown away. That doesn't make sense. So that's that. So I think Cornelius has joined us now in the green room, so he might be wanting to flag up something. You got any more comments you can see, Franklin, that we're bringing up?
Well, I mean, we had the other comment here from that the
Oh yeah,
title is electrodynamics, but you would think that this whole thing has to do with time change based on speed.
yeah,
You should have, I don't know, titled his paper along those lines. Because the only time he really mentions this whole magnet and wire thing is in the introduction. And I
yeah.
don't think that in the body of the paper, he actually gets to really resolving this problem in any kind of adequate way. I mean, I think there's like one sentence in there which says, "Oh, so this solves the problem." It's like, no.
Well,
But
part of it is Einstein's paper. He says he's going to add two postulates together, and he's first going to explain how those two postulates can be added together. And I don't think he does that. He doesn't explain how those two postulates go together. He should be saying blah 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 blah, and therefore the two postulates add together. But nowhere in his paper does he reach that conclusion. So he's talking about these two postulates that should be combined, and nowhere does he really show you how. What's he doing which showing you how these two postulates add together? He's coming up with these things about simultaneity, time dilation, length contraction, and then after bringing all those things up, you should say because of length contraction, time dilation, simultaneity, blah 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 blah. Therefore, the two postulates can be added together. But he doesn't make that conclusion anywhere. So you've got a vague statement by Einstein that the two postulates add together with no actual proof of how they're supposed to be added together. And then back in one of my sentences, he's Einstein's using the word suggest, which means he's kind of like suggesting something, and he's not providing absolute proof. Is the whole paper on relativity, which he's talking about, is he just suggesting a theory, but he's not actually proving that is the only way to look at the physics. He's not providing a definitive theory. He's not claiming to provide a theory that's definitive. And so it's sort of like it just doesn't make sense. The paper doesn't make sense.
Yeah, the comment here by Quest, I think, kind of summarizes the confusion about the title. It's like, well, how did he come up with time dilation when he was looking at wires and magnets? It did not seem to be related because obviously the speed of the magnets and the wires we're talking about here is nowhere fast enough to have any impact on how that's actually happening. But yet, the whole paper and its whole conclusions and all the math is around the slowing of time, right?
Yeah. In the paper, it doesn't properly explain things. But I think in the what he talks about later, Einstein says he was talking to his friend, and suddenly Einstein had this flash of insight that time dilation was the answer. He was talking about all these things about relativity, and he said, it's time dilation. And then he was referring to things like he was on a tram looking at this clock tower, and sort of like depending how far away the tram is, you would see different time from this big clock. So that's where you're supposed to get the idea that time is different for different observers. So
see, there's been new suggestion for his name of his paper, which has been Discovery that Time Changes with Speed. Yes, that would have been a much more appropriate title for his paper, I think. Yes, considering.
But that's sort of like that might have been rejected, just mere speculation. Sort of like
that's why he did it, because he knew that if we put in the motion of bodies of electrodynamics and mentioned Maxwell, that they would have just said, "Oh yeah, that's legit." But if you would have said that time changes with speed, then everyone would have said, "This guy's a crank," immediately.
Yeah, I think when he sent the paper in, they had to ask his friend Max Planck whether they should publish the paper, and Max Planck said yes. So they did.
Yeah, apparently that was the extent of the peer review. You know, as you pointed out, this paper has no references. How did this paper get through the review process? Apparently, Max Planck just liked it and he promoted it, and this is the only reason why.
Peer review is very, if it existed then, it was very lax. And some people think, oh, there wasn't enough science papers being written, so they was prepared to publish anything.
You just have to be approved by Max Planck. That's it.
Yeah.
That's it. That's all you need.
Max Planck. I don't know. Max Planck became Einstein's friend. I don't know if he was a friend before, but they were on like buddies terms.
So all I have to do is be friends with some famous scientist.
Yep.
And then all he has to do is review my paper and approve it.
Yeah.
And then I can be as famous as Einstein.
I think it's the same thing nowadays that you have circles of physicists working. You sort of like if you're a physics student, you get a PhD and so forth, and you've got a circle of friends around you that are interested in the same sort of theoretical. This is for theory. If you're interested in the same sort of theoretical approach to things, then you are peer reviewing each of your friends, sort of thing. So it's a circle of friends peer reviewing their same theoretical studies, and it's usually prompted by some professor as a mentor. And he's saying, yeah, the professor has some sort of control over a physics journal, so that friends peer review each other, and then it gets sent in for publishing. So you got to be in the club.
Now there's a bunch of comments here about the speed of light, right?
Mm-hmm.
So there's like, if speed of light isn't a constant, how can it have a possible velocity? Some people are saying that there is no speed limit.
Yeah.
Some people are saying, I'm not sure what that means, but
no.
Light has a speed limit. It's not a constant. One person saying, one constant exists.
Yeah.
So
there's a lot of interpretations you can put on light speed for that sort of thing.
How does that work exactly? Now, me personally, it's like light obviously is not a constant speed. It's constant in the same sense that sound is constant, which it depends highly upon the nature of the medium that it's going through. So obviously light goes slower through glass. We've slowed it to a crawl, several millimeters per second, slow. So speed, the speed of light definitely is not. That's what they always say, speed of light in a vacuum, right? But even that's not true if you take into effect gravitational effects, where light travels slower in higher gravitational fields. So it's not even constant in a vacuum. What I feel is constant is that, being an etherist, is that there's particles everywhere, and that what is constant is the amount of time it takes for one of those particles to affect another one of those particles. It just so happens that, light is one of the fastest things that can propagate through that medium, so that sets the speed of light. And if you're in a different medium like glass, then you're obviously interacting with more particles, and that is what's determining the speed of light. So, but that's just my opinion, that if there is an ether, that the speed of interaction is constant. That's why, because you still have to explain things like, well, why does the clock slow, right? It's because you're making the medium itself thicker, so that the amount of distance between 10 particles is shorter, so that for anything to have from A to B, it now has to go through more particles to get to the other side, and that's what's actually slowing the clocks.
Yeah.
Here, so that explains the time dilation without time being actually dilated, because this would still be a theory which says that there is some universal clock that you could pick on in the universe, which is ticking at the absolute fastest, and that clock would be immune to time dilation effects and could potentially be used as a fixed time reference. But that would be my theory of how that works. So because the thing is, if you say Einstein's wrong, then you're kind of saying, well, what about time dilation, all other stuff? Well, you'd have to go and prove in some other way.
Yeah.
Why that's happening. It's not that the time is changing. It's just that physically things take longer, right? It's just
Yeah.
is
Yeah. But,
what you would need to be saying, right?
yeah.
But that's kind of my comment on the whole, speed of light thing.
Okay.
But what other comments do we have in here?
Yeah.
So here's another comment here. It says, does that simultaneity does exist, but if you are moving, then the physics changes. What do you think? How does the physics change?
Well, I think simultaneity is made into a confusing mess by Einstein. That's my view on it.
For me, simultaneity is the common sense version of simultaneity, which is that, and I've seen it, taken, say, as a slice of bread through the universe, and everything in that slice is now everywhere. And whether you're moving or not, right? Although in that same example, they're saying that when you are moving, then instead of taking a straight slice, you're taking like a diagonal slice, and therefore a different set of things are happening in that slice, which is now. And that's how they're kind of trying to demonstrate the relativity of simultaneity, that your now can contain different objects, but I intuitively, I don't want it to be that way. I want it to be simultaneity is like GPS clocks, which all run at exactly the same time everywhere. And you can tell because we got a ring of these things. So maybe that's the way you could use that whole send light signals around, because you could send a signal from this clock to that clock to all the way until you get back to the original clock. And then you could compare and see, are we all ticking at the same time? Yes. Right. Or not. Right?
Yeah.
Like that game where you tell somebody the little phrase and they have to go all the way around, and it comes back to the original person and it comes back completely different. So you did it wrong. Right. But if you did have a ring of clocks that are in different positions, then maybe you could, synchronize them by sending the signal all the way around, and the original clock sender saying, yes, we did it right. Or if it came back different, then we said, no, you did it wrong. And then keep on, as engineers, adjust things until it comes out right. So that when I say 7 p.m., it comes all around and it still says 7 p.m., right? No matter where the clock is. But that would be an idea of how you make something actually simultaneous. Like the first thing that didn't make sense in the paper is like, how do you synchronize clocks? And you definitely cannot do it by sending light signals between the two, because obviously if you're on the west and east coast and the east coast is heading that way, then the light signal will get there sooner than going the other way. So obviously it's not symmetric, right? And that's something that Poincaré points out in his paper, right? You got these problems, right? You can't synchronize clocks that way. It's just not going to work.
Yeah. Okay. I'm lost where we are in the comments, actually. Oh.
Yeah, I'm not sure. I think I'm still like 30% behind here.
Yeah.
But, Cornelius is saying that the light is constant in the space-time, but what it propagates through is curved. I don't think we got into curved space in the special relativity paper.
But the way they interpret the 1905 paper on special relativity is nowadays interpreted that Einstein's talking about flat space-time and curved space-time comes later. So in the context of what Einstein's saying in 1905, it doesn't make sense, and then it needs some sort of amendment.
We do have a lot of comments about the plasma, which I'm not sure how is at all related to what we're talking about here.
No.
So that may be
there's a side talk, I think. I didn't mention anything about plasma. So.
But I think they were saying something about how the plasma reacts by time changes. Although
Yeah.
I am not exactly sure that there's anything that I can tell. Although we do have a comment here about magnetic fields. I think maybe this is along the lines of people who think that magnetic fields don't actually exist, that there's only electric fields. And if you were to look at what electric fields do, moving electric fields do to charges, you would see that it does what we call them the magnetic field. Although I really don't, I don't share in that belief. I think that the magnetic field is a distinctly different phenomenon based on the presence of dipoles.
Okay. I think there's some effect which they call due to magnetic field. So you got to accept there's something like that.
Yeah, here's another comment about the magnetism of electricity. Although this is like touching on, the initial paragraph about magnets and wires, but are never touched upon in the rest of the paper.
They've got equations which relate magnetism to electricity. So it's the same thing, different state worlds. They relate the equations together, don't they? So
here's an interesting sequence. It says everything is charged. And then it says, is light charged? Is gravity charged? And the answer to that would be no.
Yeah.
But I would say all matter is definitely charged. All matter is composed of mostly protons charged, electrons charged, neutrons. Well, they're not supposed to be charged, but I would say that they are made out of charged. This happens to be neutral, just like a hydrogen atom is neutral. It's definitely made out of a positive proton and a negative electron, I would say.
Okay, next. When was the ether actually originated? It goes back a very long time, doesn't it, the ether?
Yes, it does. I mean, that was the most popular theory for thousands of years, that they were saying that, yeah, there must be an ether until, I don't know, Maxwell came along. And Maxwell...
it's gone into lots of different interpretations of what the ether could be. And eventually end up with the idea of being called the medium for light.
Yeah, the lumiferous ether.
Then you could think of gravity needing. Then you could think of gravity needing ether and things. So there's a great deal written about ether.
I think Michelson and Morley, they did think that they were looking for this lumiferous ether, right? And they were looking for the speed of the Earth through in its orbit.
Yeah.
Now, for some reason, this very crude experiment, which had a lot of systematic errors in it, was taken as proof that the ether didn't exist.
Yeah.
But really, it was just the evidence that you cannot detect the flow of ether, at least in its orbital speed, by such experiments.
I think Dennis has put his hand up. Should we go to him?
Yes, let's go to Dennis.
I'll put him up. Hey.
Hello.
Hi, Dennis. How are
you? Weber's theory before electromagnetic waves were known was the theory that governed electromagnetic phenomena. He only believed in electric fields. I think your name, Franklin. Yeah, because Franklin said that you can explain the whole thing by just electric charge. if you don't want to talk about electromagnetic radiation. And this led G. Wesley to try to revise Weber's theory in a very subtle way to retain his the fact that his theory gave the right numbers. when an experiment was done, as long as there was no radiation, solely varying fields, you could rely on his formula. But as far as Maxwell was concerned, I hear from Bill Lucas that Maxwell called the electric field the Holy Spirit of God. Why would he do that? Well, according to the Bible, everything is made out of God's Holy Spirit. They say that everything comes from the Father, goes through the Son, and resides in the Holy Spirit. So, in other words, according to that way of looking at things, it made sense for Maxwell to call the electric field the Holy Spirit of God, because Maxwell believed, like Poincaré and a lot of other people, that everything was fundamentally electromagnetic in nature, including particles. And if you take the neutron, it decays. A neutron outside the nucleus decays in about an hour to a proton and electron, and they claim a neutrino, but I think that's wrong, and a lot of people do. Not mainstream, though. Mainstream loves neutrinos, and they take detectors down into salt mines and so on. The problem is, as David D. Hilster pointed out, the further you go down into the earth into a salt mine, the less neutrinos you detect. But according to theory, neutrinos should pass through the earth, most of them, without any trouble. So there's a paradox there. But neutrinos are firmly established in the Standard Model. And but for Maxwell, everything was made out of electric charge, and the electric charge was just the Holy Spirit of God. Then Heaviside, Oliver Heaviside came along, and he's the one who really wrote down Maxwell's equations. It wasn't Maxwell. He borrowed from Maxwell, but his claim to fame was that he got the transatlantic cable. Maxwell and company couldn't get it to go. It was like there was inductance problems or something. I forget exactly, but in order to transmit using the transatlantic cable, you had to send one. It was Morse code. You had to send one letter a minute or something like that. Heaviside wrote down these so-called Maxwell equations, borrowing from Maxwell, and showed them what the problem was and how to solve it. And I forget the exact. You can look it up. Go ahead.
Yeah, thank you. I don't think we should get into the interpretations of physics for believing in God. So,
well, then we come to the ether. Maxwell did believe in the ether, and Paul Dirac believed that the ether was a positron-electron sea. And positons and electrons are identical, except that for charge, and maybe their mass is negative, although I doubt that. But anyway, If a proton, and a positron, and an electron form what they call positronium, and they revolve around each other. But since they're close together, the magnetic field, which is 1/r⁵, trumps the electric field, which is only 1/r². For at a distance greater than 1 centimeter, the reverse is true. But for atoms and so on, the magnetic field is more powerful. But the magnetic field is not unidirectional, whereas the column field is. It extends equally in all directions. So the positronium has to have the magnetic fields lining up since they're more powerful, and rotating about themselves, also attracting by the column fields. One is positive and one is negative, so they're attracted. This has led some people. There's this black African guy, I can't think of his name right now, but he has a different theory of the Coulomb's law, which you do seem to need to explain positronium. Positronium, according to Wesley's last book with Peter Marquardt, light of photon flux and other topics. He talked for a long time about positron, electron, photon. Photons for him are positive electrons. But at the end, he gave up because he couldn't get the numbers to work right. But I am working with Ian, although Ian doesn't accept this. I have found an error in his electromagnetic theory, and this would be why he thought that he couldn't get the numbers to line up, and it's positron, electron, photons. So the positron, electron, photon seems to be a good idea. He just had to can it because his energy densities were wrong. His magnetic energy density was twice what it should be, whereas the electric energy density was correct. Or maybe it's the other way around. I can't remember now. But he made a mistake, and as a result, he had to junk all his ideas about photons being positive electrons or positronium. And so I'm sort of working on that part-time now, now that I found his mistake, I'm trying to go back in time and rework his ideas. He had a tremendously powerful intuition, but he tended to make mistakes which he would correct later on. But when he wrote this book, he was well into his 80s, and he developed, as I have, stomach cancer, and he had an operation for it, which was a success, but he was so weak that he couldn't survive the operation. It was a success, but the patient died. So a little background on this kind of thinking about photons and electric fields being necessary, being only necessary, not magnetic fields, which Weber believed, and so on.
Okay, thank you. Thank you. Yeah, you sent me some things on ether that I'll be looking into.
Yeah, they've detected the ether. A guy by the name of Giorgio Toro, which you can find on academia.edu.
Yeah,
has written a paper where he did a pendulum experiment in a vacuum. He had two pendulums, but they were different. They were the same mass, but different shape. And after he ran them for a day or two, he noticed that they weren't giving the same. They were out of sync. And he explains it by saying the Earth and all matter partially entrains the ether, but this means that there must be an ether drag. So he explains this very clever experiment by saying that what's happening here is that the two pendulums have different ether drags.
Yeah, there's a lot of different sort of ether theories. So, and it's not really clear what Einstein means about things on that.
Ian Cullen, has a Hertzian theory of electromagnetism, and he too predicts on the basis of Dayton Miller's high altitude experiment following the Michelson-Morley experiment.
Yeah.
He explains that the ether must be partially entrained by matter. But if it's partially entrained, there has to be an ether drag according to Newton's mechanics.
Yeah.
And this paper is not long, and I urge you to look into this if you're wondering whether the ether can ever be proved or not.
Yeah.
The establishment won't accept this because they claim that Michelson-Morley experiment gave a null result, but that's not. It just gave a very small result.
Yeah, we do have some
Yeah, thank you.
comments from, say, Jim Martson, who
Dennis can go. Thank you, Dennis.
Okay.
Thank
Thank
you.
you.
Bye then. Go back to the comments.
Okay.
Thank you. All right, carry on then, Franklin. Cheers.
Yeah,
Thank
Jim
you.
Martson has been giving some
Dennis.
interesting comments here. I'm trying to look for them.
Okay.
But, the first of which is that if the existence of the ether was determined by your inability to detect it in the Earth, that, the problem is that if the ether is being entrained on the Earth, specifically the ECI, that the speed differences we're looking at there are like something like 350 meters per second, which is too small to be determined by, say, the MMX.
Yeah.
And that later, here's his first comment here, that this is too slow to be detected by classic MMX with mirrors. But then later, he points out that we are able to detect that small amount of speed difference. Let's see, he says here. So Professor Howard Hayden showed that the 1997 Brillet Hull detected the 350 meters per second, but Brillet and Hull discarded it as spurious because it would disprove SR.
Yeah.
Which is kind of interesting. They say the experimenters did detect the ether effectively, but then they discarded their own results because it would disprove special relativity, which is really terrible.
You get a lot of stories like that.
So it's like if you use MMX as a standard for disproving the ether, and we find out that similar experiments do in fact show that there's an ether, it shows that it is relative to the ECI frame, and that Earth must be entraining it, and that we can see the rotation, that we can definitely see the 24-hour rotation of the Earth in experiments. There's no doubt about that.
Yeah.
That then we must say an ether must exist, right? It must.
It must exist, yeah.
It must exist.
Waves need a medium. Light waves need a medium.
Of course, it would be much better if we could say what it is and then do an experiment, and actually show that it exists. I mean, that's why I personally advocate to say that the ether is it's like a sea of neutrons, effectively. So we know what neutrons are. We know what positrons are. We know what electrons are. So we should be able to do some experiment where we eject these things out of space, right? you think that if all of space was filled with positrons and electrons, we could arbitrarily release them, right? And get an electron and positron to pop out of nowhere, right? But wait a minute, we've already done that experiment. It happens. It's called pair production.
Yeah.
So it's like, okay, well, you've already done my experiment, but yet you still don't believe that space is made out of positrons and electrons. You know, we can do other experiments. Like if space contained all these charges, then they would affect the spectra generated by atoms, because they would be deflected slightly by the presence of all these charges, right? You'd think that all those charges would get in the way. But wait a minute, we have done that experiment. It's called the Lamb shift. And they concluded exactly that same thing, that there must be charges spread throughout space that do that. So, well, let's see here. What other experiment could I dream up to show that, you know, that this ether actually exists? Since you've already done the two most obvious ones, and you still don't accept that space is filled with positrons. But that's my own little rant. I may need to get off of my soapbox here about, you know, how do you prove that an ether actually exists, right? Well, let's see what else we got going on in the comments here.
Can you add the comment to the screen? Where are you? We're running out of time.
You know, Quest is asking me, the space is made of positrons and electrons, or did you mean ether? Well, I mean that the ether is made out of positrons and electrons, right? Now there's
quantum vacuum, Heisenberg uncertainty principle, virtual particles, and all that sort of thing.
But getting back to, say, our discussion, see, if space is made out of material objects with particles that can be tracked through time. I mean, this is the most ridiculous thing that Einstein says, is that, you know, there's an ether, but it's made out of particles that cannot be tracked through time.
Yeah.
And that's an oxymoron, man. That's if there's an ether, it's made out of particles that can be tracked through space and time. That's what it means. But it would establish an absolute fixed frame, right? So if there is a sea of particles, let's say a sea of neutrons, then you would be able to determine with absolute precision and certainty whether you are in motion relative to that stationary sea, right?
Yeah.
Now, see, I'm not even sure that would even
I don't know if
relativity.
Cornelius wants to say something. His hands are moving. Should you add him and see what happens?
Oh, yes, Cornelius' camera is on, yes. But he's still muted. You have to unmute yourself.
Yeah, okay. I was unmuted earlier. This idea of a particle-filled space, though, if it's the other way around, if ether is simply a bond material, a continuous bond material, and gradients in that bond can form focal points and become have the characteristics of particles, then that actual bond material within which those patterns are moving cannot be detected. Its motion can't be detected. The only thing that can be detected is the waves, the patterns that are moving within it, not the media itself. And that's what Einstein is getting to when he says that you cannot detect the ether. What you can detect is the things moving through it. That's also why he's using light as a reference point, because you can't use ether as a reference point. The light speed is consistent throughout the ether based on the density of the energy within the ether, and the ether would be then the tension. That's why curved space is essentially a gradient in that tension, which is basically gravity is a curved space on a larger scale, and every molecule, every atom, and everything else that light has to travel through is a curved space. So the greater the curve, the slower the light, and the closer you get towards the center of a particle, the particle's curvature, the space's curvature is much greater to create that particle, and therefore light has to slow down as it goes in and out of that sea of particles, if you will, just like you would have to, slow down going through foam rather than this, uninterrupted media. So the idea that particles are primary is probably what's blocking the understanding of Einstein's description of ether.
Okay, thank you.
Yes, well, that's certainly one way to understand it. So there are many different viewpoints on this. Certainly, that would be the contrast between people who say that the ether is in fact the electromagnetic wave. I mean, I think that, well, the electromagnetic field is the ether, right?
Yeah.
They're just saying literally that is the thing which fills space. Many people will try and say that the electromagnetic field itself is fundamental in some way. But it seems we've come to the end of our time here, so I guess we should probably wrap it up.
Okay. Thank you, everybody. So I'll close it down. Thank you. So basically, the point of view being tried to put across is that Einstein's paper maybe should be accepted, but it doesn't really make sense. Thank you. I'm closing down now. Thanks, everybody, and goodbye. And straight.